This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. As a software engineer, chances are you've crossed paths with MongoDB at some point, whether you're building an app for millions of users or just figuring out a side hustle. As the most popular non-relational database, MongoDB is intuitive and incredibly easy for development teams to use. Now with MongoDB Atlas, you can take advantage of MongoDB's flexible document data model as a fully automated cloud service. MongoDB Atlas handles all the costly database operations and admin tasks you'd rather not spend time on, like security, high availability, data recovery, monitoring, and elastic scaling. Try MongoDB Atlas for free today. Visit mongodb.com/cloud to learn more.
Welcome to Software Engineering Radio. I'm your host, Simon Crossley, and today I'm very pleased to say my guest is Josh Long. Josh is Spring Developer Advocate at Pivotal, a Java champion, and prolific within the Java community. He's previously hosted Software Engineering Radio and currently a host of both a beautiful podcast and Spring Tips videos. He's co-author of 6 books on Java and Spring and an instructor on live lessons training videos. So Josh, thanks for taking time from your busy schedule and welcome to Software Engineering Radio.
Thank you very much. It's my extreme pleasure. Thanks for having me.
Awesome. And where does Spring Boot fit in that? What is the kind of mission statement of Spring Boot?
Great. So
in that ecosystem?
Right. And so we realized that Spring was a very flexible solution, but it wasn't necessarily a very opinionated solution. We'd had a go at something called Spring Roo, which was an opinionated approach to Spring, but it was based on the idea of code generation. And by the time we got to 2013, we didn't really need code generation. We could do all the things that we wanted to do in code, right, without actually having to synthesize that code. And we could get the effect of code generation by doing by generating classes, right? We can actually pre-compile or pre-generate classes that get loaded by the class loader. So it's not even reflection; it's just dynamically generated classes that run just like any other class would run. So there's this incredible opportunity, and we wanted to be able to support certain kinds of applications that would run in a cloud environment. And this was all contemporaneous with a Jira issue that landed on the Spring Framework Jira years ago, saying, "Hey, we'd like some support for running Spring in an embedded web container." Right. So rather than deploying a .war into an Apache Tomcat or something like that, let's use embedded Jetty, standalone Jetty that we can just public static void main into a server. How do I deploy Spring into that? And at first we thought, well, this will be a low-hanging kind of thing, and it turned out quite the contrary. There's actually a whole host of issues that come up when you try and do that, and that began this discussion that turned into the Spring Boot. Right, that process took more than a year. So the way that enterprise applications always used to be developed with back in the day of EJBs was you needed an application container. Yeah. And
Spring Boot is embedding the container within its own jar file.
Right.
That's a big change. What drove that change?
Very good point. And I hadn't even thought about that. That's true. The original sort of use case, the original sort of revolution here with Spring was to say, okay, well, rather than depending on this critical infrastructure inside this giant unwieldy application server, I'll control as much of that logic in my code proper as possible. And eventually with Spring Boot, we took that one step further and even took control of the web server. That was sort of the last bastion of like things on which we depended in a typical application server, right? That's the last thing in the application server layer that we still depended on, that we didn't control ourselves. The thing that drove our use of Spring in the application server world was to say we want to be able to control the reason that we want to control our code, the reason we want to have a hand in how our application behaves at runtime and not be in a situation where we depend entirely on this application server to make our application whole, right? That was the situation you had before. You would have to deploy these incomplete class files. These are classes that would be deployed into the application server, and it would be managed by the lifecycle of that application server. You couldn't easily test this code without the application server because it didn't mean anything without the application server. And that meant that you were at the whim of the lifecycle of the application server. So if it was slow and particularly burdensome to spin up a new instance and redeploy and refresh and all that stuff, then you just had to wait, right? Very, very painful. So Spring embeds the application server. We embed the application container, and we can do a lot of things once Spring controls the application container, whereas application servers don't typically introduce new features outside of the band, out of band of the specification lifecycle. Spring could deliver all sorts of new stuff. So we were very quickly able to reach parity with what any application server could do. And then that was 15 years ago, right? And now ever since then, we've just added new features, right?
Okay.
I'm sure there's a knob or a widget on some application server that Spring doesn't support, but generally all the things that you want to do, manage transactions, expose web services, talk to databases, message queues, that kind of stuff, all the big sort of checkboxes, right?
So by embedding the application server inside your application, you've got something that has fewer dependencies, it's better isolated, and it's easier to develop, test, and deploy. If you're packaging all that stuff in, have you lost any flexibility? You used to be able to package an application, and then the idea was it was portable. Are we tied to one specific application container?
Okay, so I don't know that we've got less dependencies. I suppose you could. So the nice thing about Spring is that it's an a la carte kind of thing, right? You can choose, you can use what you can pay for what you use. So if you just want to build a web app, great, then just bring in the dependency that allows you to build web apps, and Spring will support you in that context. If you want to build a web app that talks to a SQL data store, then great, bring in JPA or MyBatis or Java OOQ Juke or just raw JDBC template, which simplifies JDBC programming. All of these are fine options in that context, or the new Spring Data R2DBC, which is for reactive programming, right? So you can bring in as you like support for different integrations, and your dependencies then will grow accordingly, but you're not, you don't have one single monolithic dependency. It used to be that you had the application server, and if the application server provided what you want, great. If not, then you had to fight the class path of the application server and make sure that you can add your own dependencies. So you had your dependencies spread across two different logical sort of domains. You've got your code and its application dependencies, and then the application server itself. And you needed both in order for any application to work. Now you've just got one discussion. What dependencies does my Spring app depend on? Because when you write code with Spring, one of the big original innovations, one of the big original sort of changes or dismantling of the existing status quo was that Spring gave you this application context. It's just a big old bag of beans. I like to say it's a container that contains your objects. And when I say objects, I mean truly just any kind of object, right? These are just regular old objects. These are called POJOs, right? We talked about POJOs. This is, I think we're the first to really popularize that term, this idea of a plain old Java object. And the reason that we have to have that term, and it may seem simple, it may seem ridiculous, but at the time, people were accustomed to deploying things into application servers, and these were very weird. It was very weird. These are mutant classes. They extend that. Like, for example, EJB2, right? EJB3 is markedly better, but look at EJB2. On average, you'd have at least 3 different interfaces you had to implement, not to mention a bunch of others that you'd have to generate or code generate. It got to the point where if you're doing everything right, you could easily have 5 or 6 different classes that weren't your business logic, just to adapt that type to the runtime expectations of your application server's EJB environment. And so these weren't regular Java objects. These are monsters. These are things that required, they gave nothing and they took away all sorts of time and complexity. So whether they added complexity and they took away time. So we coined this idea of, hey, just write an object, wire the object up as you would any other object in good old object-oriented fashion. And the relationship that these objects have, we can express using a dependency injection container. We can say, here's how these things fit together. I'm going to write code that depends on a data source, the definition of which I'll keep external to that code, to that object. I don't want my dependency being hard-coded in each single class. Put another way, the work of resource initialization and acquisition, we extricate from any one particular class. We centralize it into a configuration in Spring, and then we can easily inject that reference wherever it's needed. But you are still wiring up your objects, and you're doing so at first in the back then it was a textual representation of your object graph. And the reason we did text is because there were no annotations at the time, right? Java 5 hadn't come out. There's no way to provide metadata about your objects in the Java code itself. You had to do so externally. And the benefit of that is that when you are wiring up your objects, when you're telling Spring how to wire up your objects, it now has a perspective on how your objects fit together, and it can interpose itself in between the seams of your object graph. It can say, oh, you wanted this thing that's a POJO, that's just a regular old object with methods. You want that thing to start and stop a transactional boundary, to demarcate a transactional boundary upon invoking a method on that object, right? So you've got a service and you want, container managed transactions, right? Well, that's a thing that's pretty interesting that came from EJB, right? It was arguably much more difficult to configure, but it was there, right? It's a very interesting novel feature. And so if you're using EJBs, that's a nice thing you can enjoy, is just container managed transactions. So what about abstracting out that same mechanism? What about doing the same thing for Spring, but not doing it so in a way that it only works for transactions? We want the ability to add, to advise, or to augment your objects to do these interesting things like container managed transactions and security propagation and whatever else in a generic way, right? So Spring can do that because it has visibility into this just object graph of yours.
So I've got an amazing wealth of features available to me as a developer with the Spring framework. Everything's managed as POJOs so that they're lightweight and easy to test, and I can assemble them in ways that I want, and I can pull in all these extra dependencies to handle the enterprise features that I need, like databases and message queues, WebSockets and streams. So I've got a lot of capabilities to play with. At the beginning, you talked about consistent ways of delivering key applications. How does Spring Boot help simplify this wide array of possibilities and complexities to make life simpler for developers?
That's a great question. What we've always tried to do is to find ways to plug in new functionality without foreclosing on the opportunity that somebody else might use the underlying mechanism to do the same thing in a different way, right? So, case in point, I just talked to you about this sort of generic augmentation of classes, right? The mechanism that we used behind the scenes there is something called aspect-oriented programming. Aspect-oriented programming is an idea that we kind of nurtured and fostered from academia that we then sort of made enterprise ready. And I don't think most people deal with AOP today in 2019, but it's still there. And it's very much what allows us to do what we do in a generic way. It's a way of saying, I want to match a particular pattern, and that pattern is a pattern that describes, for example, a method is invoked, or a field is set, or a constructor is invoked. Something very generic. You can say, on these events, whenever this thing happens that I'm describing in what's called a point cut expression, then call this method or call this object, invoke this object in some way, give this object a chance to be aware of the fact that you're calling a method, and possibly even change what happens to that method on its invocation by giving it access to the parameters of that method, giving it access to the return value of the method, etc. That mechanism sounds kind of it sounds very weird, I think, if you haven't seen it work before. But in practice, it allows us to build very interesting things. Like I said, like we built container managed transaction management with that fundamental technology, but you could too now, is my point. It wouldn't be that hard because we have this AOP foundation. We expose the mechanism that we use to teach the Spring framework new features, new tricks. There's obviously you have to write APIs and all that stuff, but the way we can introduce that functionality into your code in a way that's kind of just declarative, right, for you. You don't have to change your code, you don't have to extend a bunch of types and so on. The way we do that is through AOP. When it came to Spring Boot, we realized that AOP, there were sort of three different pillars to a typical Spring application. There's a portable service abstractions, that is to say the APIs on which your application depends that support different use cases, like, for example, talking to a SQL data store.
Yeah.
And that's well supported by something like the JDBC template or whatever. There's a dependency injection. That's this idea that you have a container that has an understanding of the relationship of the objects in your application's object graph, and it can let you write code in terms of simple interfaces, and then you get at runtime you get a ready to use, already initialized instance of that object. So you keep your code clean of any particular explicit dependencies, which, by the way, promotes testing, right? So I can take my object that was written for a javax.sql.data source. At runtime, I can give that thing a pointer to or a reference to a PostgreSQL, a Hikari CP managed connection pool that's in turn managing a PostgreSQL data source. I can do that at runtime, but in my test, I can just use a mock because the code was written in such a way that it just expects javax.sql.data source, and my code isn't aware of the specific variants, right? So that's dependency injection, and then we've got AOP. And it's aspect-oriented program. Those are when we first talked about Spring, we talked about that triangle, the three pillars of what makes a Spring app work. And I think the big revelation in Spring Boot is to add another corner there. So now we've got more like a square. And that corner is something called auto configuration. Auto configuration is the thing that allows your application to, if you appreciate that there are different ways to pull together your objects to do something, then you can understand that is, each time you add a new library, each time you add a new feature to Spring, each time you add, the JMS support or the RabbitMQ support or the Kafka support, or you add the servlet support or the reactive webflux support, each time you add a new feature to a Spring application, there's a corresponding amount of configuration that needs to be done. You need to wire up the embedded web server. You need to wire up a connection factory to talk to JMS. You need to wire up your data source to use the JDBC support. There's all this configuration, and a lot of that looks the same from one app to another, right? We don't want people spending their time recreating this code, and at first we favored flexibility. We said we give you the ability to be explicit about how these things are wired together, as opposed to what you could have expected back at the time with an application server. An application server did 5 tricks. Let's just say, I'm sure let's say 20 tricks. Okay, it did 20 tricks at the time. It's different now, but it did 20 tricks. But that was it. If you wanted to do something else, you were completely on your own. You have to start from the bottom up, right? It did those 20 tricks very well, but outside of that, there was no way to add a new trick to the application server. You just had to write code in your application. With Spring, the number of tricks we can do is virtually limitless because it's the same kind of stuff. If you want to use one of these features, you just create the objects that then instantiate these features, and that gets to be tedious after a while. You get to see that the flexibility gives you flexibility. That the sort of possibility there is interesting, but I think a lot of people have, being brutally honest, there's a lot of apps are very, very similar. How I configure my application in 2019 when I build a web-based application, it looks basically the same. I need support for JSON and XML marshalling. I need support for rendered views. I need support for form binding and validation. All these kinds of things. And if there's some exception to that, I'll let you know, right? But you can go ahead and just give me the absolute sort of commonplace default, and I'll work with that. And that's the sort of that came from. I think we owe a huge debt of gratitude to the Ruby on Rails community for giving us this idea of convention over configuration.
Right.
But with Ruby on Rails, with Ruby on Rails and with the application servers, you got convention over configuration, but if you wanted to undo those conventions, you were in trouble. Because either, as was the case with the application server, there was no way to undo it. You couldn't just use part of an application server's EJB functionality, right? You couldn't just use the engine underneath the EJB server and use that for transaction management or something like that, right? Well, that's not actually a good example because you could actually do that, but you couldn't extract parts of the application server and just use part of it. You couldn't just turn some things off and whatever. Same thing for Ruby on Rails in the beginning, right? A lot of that was code generation, and it generated code, and there were some small toggles, knobs and levers here and there, but generally you were stuck with what you got, right? It wasn't gonna do something differently, radically different. It was optimized for a particular use case. So we wanted to have that same velocity that you get with convention, without sacrificing the flexibility, because that's one of the things that Spring is so good at is serving these other use cases that aren't served by the 80%.
So if I'm writing an app and it's a RESTful API and I'm going to use a database, then if I choose my Postgres database, then Spring Boot will detect that I'm using Postgres and load the appropriate drivers and wire them up in the default way so that the database is ready to use. Is that how it works?
Sort of. I mean, very close. So we have this thing, like I said, we have this thing called auto configuration. What that is it's just a bunch of configuration. It's just it's a class that contains the definitions for objects that will be useful to you in a particular context. So suppose you are using a Postgres database and you've got or rather you're using a SQL data store. You've committed to that, and so as such you have the requisite JDBC dependencies and you have a SQL data store driver on the class path. Well, Spring, ideally something should be able to look at that and scan your class path and say, hey, you've got the types that are required for a SQL data store connection to be made. And really, the only thing such a thing would need from you is, let's say, the URL and the username and password, right? Because it can look at everything else and it can go, oh, I've already got a connection pool on the class path. I've already got the JDBC driver on the class path. I've already got the JDBC template or JPA or MyBatis or whatever. I've already got all that's required to allow you to be productive talking to a Postgres database. So assuming you give me 3 little properties, like literally just property values, like a .ini property file or a YAML property file. Assuming you give me, or like a Java properties file, right? Like a properties capital P. Assuming you give me those 3 properties, the username, the URL, and the password, Spring can hydrate a data source that's backed by a connection pool that is talking to your data store, and it can stand up the JDBC template or JPA or whatever. It can take all of that stuff and turn it into stuff you can just use. You can write your code and you can tell Spring, hey, I would like a reference to the JPA entity manager, please. And that JPA entity manager is already aware of your data source, and it already knows about JTA if you've got the dependencies on that for that on the class path, etc. So it already knows about all the stuff, and you get to the business of just saying, I'm going to write an object and save it to the database. I don't care about wiring up all that stuff. It's just done for me automatically. And that auto configuration mechanism technically is a generic thing, right? You can take advantage of it as well. So the way it works is Spring starts up. There's a service loader mechanism. Basically, Spring starts up and it looks on the class path in the meta inf directory of any and all jars in the class path. Therein, it finds a text file called spring.factories, and therein it finds a line saying org spring framework boot auto configure enable auto configuration equals, and then after that line, after that thing, that variable name, basically it says equals, and then there's a long list of Java classes, and their commons are limited. So my autoconfig, comma your autoconfig, comma whatever, and these are the auto configurations that live on the class path in these jars. And Spring Boot ships with dozens, maybe hundreds of these little auto configurations. Spring Cloud, same thing. These are auto configuration classes that live in these jars, and they're automatically loaded. Every single one of them is loaded when your application starts up, which can be a bit, I think, nerve-wracking. For example, if you're starting up a Spring Boot application and you see that you've got auto configuration there for Kafka, but you don't have Kafka in your application, what on earth could that possibly be doing? Well, we can't afford to just start creating objects and then have them blow up with class not found exceptions. So Spring does some very smart things where we look at these conditions. These are annotations that are added to your configuration classes that express constraints on how these objects are to be created, or the constraints on the conditions in which these objects are to be created. One of those conditions is, hey, does this class exist on the class path? Right? Can I load this class at all? If this class isn't here, then don't bother trying to instantiate this object that I'm defining here, because it will surely fail. I'll get a no class def error or a class not found exception.
Yeah.
Right? So we have some very smart conditions here. We can also look at other things. We can say, oh, did the user add this library to the class path? We can detect that through the use of this conditional in class. We can detect if there are certain properties. If there's an environment variable set, we can detect if there's another object already created. And the result is that Spring tries to instantiate every single one of these auto configuration classes that it finds that serve every kind of conceivable use case. but it only actually launches just a very small subset of those, because it short circuits the evaluation for the very large majority of them, because you don't have the requisite libraries on the class path.
So we've gone from a situation where we could configure everything and had complete flexibility to do whatever we want, to a situation now where I choose what things I want to put on my class path. I choose my dependencies, and then Spring, through these auto configuration and conditional annotations, will assemble a framework of an application which is probably going to do what I want to do with the tools that I've put on the class path.
Absolutely, but those conditionals also allow us to ask questions and to seek input, basically. So we can say, okay, well, we can configure a javix.sql.data source for you, and we'll do a good job. We'll give you a connection pool, and it'll be the pretty good settings and all that stuff. But we do need some of your input. We need, we can't just guess where your Oracle database lives. You need to tell us, right? So we expose a mechanism, an application.property file, and you specify, oh, well, my spring.datasource.url equals this, and then the configuration will read that property and use that to hydrate the rest of the machinery, right? Same thing for those conditionals, allowing us to look for the presence of other objects in the application context. So if you've already explicitly provided a bean of type javix.sql.data source, then we'll just fall back. We'll just defer to you. We assume that you know what you're doing, and you've provided a data source. We won't configure one for you, right?
Right.
You can have your cake and eat it too. We'll do 90% of the work, but you provide the data source.
So if I've got very specific requirements for my Hikari connection pool in my production system, I can code that up exactly the way I want it. Spring will use that instead of its default auto configuration.
Absolutely, and then the other way that you can exert control over this configuration is going back to this idea of you add libraries to the class path, right? Those are the triggers that activate functionality in that auto configuration. So each time you add a library that contributes a type that one of these auto configurations needs, each time you add that to your class path, just by adding it to your Maven build, then that auto configuration lights up and it gets run when your application starts up. So you've got all these possibilities, but unless you have the types on the class path, they don't run. The implication here is that you can either add those dependencies yourself. You can go through and add all the going back to the JPA example, you can add the entity manager, you can add an implementation of JPA using Hibernate, you can add transaction management, and you can exclude the redundant conflicting logging libraries. You can do all that yourself. But since dependency management is key to the way Spring works, we've also tried to simplify that. We have this thing called a starter. A starter is a Maven dependency. It's a dependency you can use in Maven or SPT or Gradle or whatever.
Yeah.
But it is in turn just it does nothing but import other dependencies. There's no code in these starters. All it does is it transitively brings in other dependencies, and it level sets any version conflicts, so that if you have log4j whatever over here and log4j2 over here or whatever, we make sure you get the same version of all the libraries, or you don't have one that's 0.1 and then 0.2 on the same class path. So the starter dependencies allow you to say, hey, I just want to use the starter called Spring Boot Starter Data JPA. And that's it. That will bring in JPA, it'll bring in Hibernate, it'll bring in an entity manager, it'll bring in the right versions of logging libraries, it'll set up transactions for you, it'll bring in the javix.transaction API, it'll bring in all the specification type. It'll just do all of that stuff, and suddenly you're off to the races. And by virtue of adding that to your class path, that in turn transitively brings in all that other stuff, and that in turn allows the auto configuration that detects these types and then configures JPA for you based on the presence of these types to work.
So all I've done is provide my URL, username, and password, and I've got an application that is talking to a database.
Yeah, knock on wood. Yeah, and you can override it. You've got gradients of configuration there. Property files might be your first line of configuration, but then you can you can override objects in the graph if you want, or you can just not use the auto configuration at all. You can just exclude it, right? And you can do everything yourself.
So is there a menu of the starters that are available, the things that I can put into my application?
It's my second favorite place on the internet, start.spring.io. So start.spring.io is a really amazing piece of software. It's a modest little application. I mean, if you look at the code, there's actually quite a bit going on, but what it's doing, all it does is it gives you a one-stop shop for all these different starters. You go there, you get a bunch of checkboxes, You can walk down the aisles of the supermarket Spring initializer, and then you just choose the dependencies you want. You click a checkbox, or you can use a auto completion search box, text box thing. But either way, the result is that you specify that I want JPA, check. You specify that you want the support for security and OAuth. You specify that you want the support for talking to Kafka. You specify that you want a reactive web server. You specify that you want, service registration and discovery with the console or Zookeeper or something like that, or Netflix Eureka. You specify that you want distributed tracing, right? You bring whatever you want. There's a checkbox there. Let's say that you want to use Spring Boot in a Microsoft Azure application. Great, then go ahead and add the Active Directory support there. Or if you want to use it in Google Cloud, go ahead and choose the Google Cloud Spanner dependency there, right? There's all sorts of checkboxes there. You add them to your application, hit generate, and it gives you a little zip file. And that zip file contains a pre-generated maven.pom.xml, maven.pom.xml, or a build.gradle file. It gives you a skeletal directory structure, source main, resources, Java, and a skeletal public static void main entry point class. And that's just fit for import into your favorite IDE. Now, I did that the long way. I went to the start.spring.io and I generated the zip file there. But we also have that API, that start.spring.io, also powers a API, an HTTP API that you can then use to generate new projects. So if you go to file new Spring Starter project in IntelliJ, or Spring Tool Suite, Eclipse. Spring Tool Suite is our amazing set of plugins and extensions on top of Eclipse. So these are open source. You can just add them to any Eclipse distribution, and you can go to the file new starter Spring Starter project, and it'll in turn run you through the same wizard, the same dialog flow that you would have gone through on start.spring.io. It'll go through that same flow, give you the same exact options, and generate a project that it'll then just import for you automatically in Spring Tool Suite. Ditto for IntelliJ Ultimate Edition, ditto for NetBeans and the Spring Boot tools for NetBeans. So you don't have to go to the website. You can actually, all major IDEs, and Visual Studio Code as well, right? Because that shares the same plugin as the Spring Tool Suite does. The same support for Spring Boot that we developed for Spring Tool Suite also works in Visual Studio Code and in Atom and in Emacs because of this, because all of it is based on language servers, right? So
okay,
yeah, anything you want to use.
So it's right there in the IDE. File new, and I can stand up the framework for an application that's gonna be a RESTful server or a web server, some sort of messaging system.
Yep, absolutely. And it's just, but after that, you're on your own. You've got a Maven project with a few dependencies that have been added for you, and each dependency corresponds to one checkbox that you selected back at the initializer. But it is just a Maven project. You don't need start.spring.io anymore to be able to change that. You can add dependencies manually if you want. You can say, I want to add Spring Boot Starter, whatever. Maybe I forgot one, so I can add the dependency myself. That's fine. It's just a Maven project or a Gradle project.
So I'm not stuck in a place where I might be with some code generation.
No.
Where it's a one-way process, and it's not easy to go back and change your mind once you've made any changes, because I'm working with dependency injection and AOP and just through standard service APIs. I'm just working in Java code. Yeah. But we focused a lot on features for developers, but what about other interested parties? When the apps go into production and they're in operation, what features has Spring Boot got to help the app running in production?
So that's a great point, and I'm surprised I didn't even bring it up myself. Spring Boot is production. It's an opinionated approach to application development, and when I say opinionated, we have a strong opinion about how applications should run in production, right? We want you to have, we already mentioned some of the obvious things. We don't just give you a data source, we give you a connection pool, right? We know that applications are going to need a connection pool. But I think one of the more, and we also give you an embedded web server, right? We say, rather than deploying this beautiful piece of code into this otherwise, this other unknown quantity that is an application server, we're going to embed the web server in the Spring Boot app. And so all you need to do to run your Spring Boot app is to say Java-jar, right? Or even better, you can use our executable plugin, and then you just do ./myjar, right? And either way, the result is you have just a self-contained package that contains all your dependencies, all your logic, all your functionality, and even your web server. It contains your data source, your connection pool, all that stuff in this jar. That jar is suitable for deployment anywhere, right? So if you have an opinionated cloud platform like Cloud Foundry or Heroku or Google App Engine, although I'm not sure if Google App Engine does .jar. I think they do, but I'm not sure. But either way, you should be able to just take that and run it without any issues. If you want to deploy it as a .war, you can do that as well. You can deploy it into an Apache Tomcat, right, or WebLogic or whatever you want, right? Any standard server container will work. And I guess, and by the way, that goes back to your discussion about portability. Your question about that, I forgot to answer that. Yeah, you have, in that we can be built on top of, we can run on top of servlet containers and things like that. You have portability if you want it, right? And we are using JPA, which is a standard, right? So we support JPA among half a dozen others for SQL data store access alone. In that we have support for those layers, you do get portability if you want it, but you're still working on top of Spring. So it's your app and then Spring and then the underlying runtime. Spring gives you portability not through the use of specific types, although that's a big part of it, but through dependency injection, right? We can let you write code that talks to a JNDI bound data source in one environment, and then use a mock data source for test in another environment, right? So it's the same code, same object. It's just that because it's expressed its dependency on a JavaScript.SQL.data source, it doesn't really care where that data source comes from, whether it originates in a JNDI context in WebSphere, or if it originates from a in-memory H2 for testing or whatever, right? That's the real reason you get portability.
So that's just set by the properties that I've provided when I start the app up.
Well, yeah, I mean, something creates a data source in your application code, right? Whether that's Spring Boot or you or whatever. But in your test, you don't want to talk to Oracle, right? You don't want to talk to Microsoft SQL Server or DB2, whatever your production grade or production server is. You want to just talk to like a mock, right? So it can do unit tests. So we let you write code that is amenable to being used in either context without change, right? You change the configuration that gets fed into the creation of the data source, and that results in a data source that gets plugged into your object. Now, that's one of the reasons we have portability, is we have this indirection, and that indirection serves you. Now, if you're talking about portability, there's not two different versions of Spring, but nor are there two different versions of Log4j. So I'm not sure. I don't find that particular argument persuasive. I've never understood that whole idea, right? There's not two different versions of Linux either, right? I mean, there are, but there's not, the core, the kernel is, you don't want two different versions of the kernel. You want the same one. You want to know that it's going to work consistently. So
that helps with the deployment.
The last thing I forgot to mention, we give you a set of endpoints called the Actuator, right? So you add Spring Boot Starter Actuator to your application, and Actuator, as I understand it, is a physics term or engineering term. It describes something that takes a little bit of energy and turns it into a lot. And the Actuator, in our case, is just a set of operational management endpoints that surface information. It makes visible information about the health of your application, things like metrics, things like the uptime, things like the health of given subsystems in the application, all these things that you would want to know to understand if this application needs help, if it's sick, if it can't talk to something it needs to talk to, etc. Right? Who better to articulate the state and health of an application than the application itself?
Is that on top of the JMX API, which is the management extensions? Or is that something separate?
It's an abstraction, so you can turn the Actuator data into JMX endpoints. We can do that for you automatically. You can also turn it into HTTP endpoints that are mounted in your web application under /. By default, it's /actuator/. So you go to /actuator/health and you get the health information, or /actuator/metrics and you get the metrics information. And then even talking about specific features, you can see the metrics support. I don't want to see my metrics in a JSON endpoint in the web most of the time. Most of the time, I want to publish those metrics to a time series database, right? Something like Datadog or
Prometheus
or Atlas from Netflix or whatever. So we have a project called Micrometer, which underpins Spring's metric support we developed it. It's generic. It doesn't need to be. You can use Micrometer without Spring, but we use it to let your code talk to whatever you want. So it'll publish those metrics that we're capturing for you. And you can capture your own metrics too.
So I can write my own timers and counters and have them published alongside the metrics of CPU usage and
Yep.
everything else that's been collected about the application.
Yeah, and I think that's actually, I think CPU and things like that, almost anything will give you that information these days. The JVM can give you that information. Your cloud platform can certainly give you some of that information. But I think what much more meaningfully is sort of key performance indicator kind of metrics, right? Like, how many transactions do we have per hour or per minute or per second? How many users have signed up? How many orders have been fulfilled? How many messages do we set? What is the queue depth of my queue, my Random queue or Kafka queue? How many messages do I have sitting on queue every second, right? And I can use that information to say, okay, well, our server is clearly not keeping up. The load is growing. Let's use the autoscaler in Cloud Foundry and tie that to one of these metrics and just spin up a new instance. Or 10 new instances. You can do the same trick with Kubernetes. You can do it with whatever, right? But that information is there because we have this metrics collection abstraction.
Fantastic. And are there any other kind of runtime reports that I can get from the actuators?
Yeah, goodness. There's a dozen or so that come out of the box.
Right.
I mentioned health and metrics, and there's things like you can get a thread dump, you can get the heap dump, you can get all sorts of stuff there. But then there's also ones that get contributed by dependency. So other libraries that have things that are observable can contribute their own actuator endpoints because it is a framework unto itself. So you can register automatically through the use of auto configuration these new endpoints that then get mounted under /actuator. So let's say that you're talking to the Spring Cloud config server. The Spring Cloud config server is a server that you can use to store configuration keys and values, and you can do so in a secure way if you want as well. And it in turn is backed by a Git repository. Well, that config server itself has dependencies. It's when your client connects to the config server to read the keys and values from that config server, you're dependent on that, and that in turn is dependent on a Git repository, a Git service somewhere, on your local machine, under SSH or HTTPS or something. So when you add the Spring Cloud config server client to your application, the starter for that, when you add that in, it automatically gives you an actuator endpoint that tells you about the state of the config server itself, right? Because of course you want to know about that. So that's just one example, but there's countless examples of them throughout the Spring ecosystem of things that add their own actuator endpoints, right? There's even stuff in the ecosystem at large. People have contributed their own. One that I think is really brilliant was a gentleman named Toshiaki Maki in Tokyo. He created a graph viz actuator endpoint. So it actually creates a picture of your beams and of the objects in your application context and how they're wired together. It's a graph basically that shows you all the objects and their relationships.
Okay. Graph viz draws boxes and lines with arrows between them.
You got it.
So depending on what the actual class path is on your production app, you can get a picture of how the Spring application context has wired the beans together.
Yep. I mean, that's just a really cool example, right? You can these actuator endpoints can be anything. They don't have to be JSON. They can be all sorts of different kind of information.
Cool.
Yeah.
Yes, I like the sound of that.
And it's generally inspiring to see what people do with that because observability is so key. It's a big deal when you're building a monolith application, which you can do with Spring Boot, sure. But it's also it's a much bigger deal when you're building a microservice, right? Microservice systems tend to have lots of moving parts. They're characterized by that, if nothing else, right?
Yeah.
And so finding an issue is much more difficult. It's markedly more difficult in a microservice architecture. If you have a null pointer exception in the monolith, it's not hard to say, where's the null pointer? I know it's in the monolith, right? If I have a memory leak in the monolith, you can ask, where's the memory leak? Well, it's in the monolith. But what about a microservice system? You have no idea. So getting that visibility is paramount, and that's why it's just you just add Spring Boot starter actuator, and you've already got a working set of endpoints. You can customize it and maybe unlock or secure, or maybe going the other way, you can secure some of those endpoints with a few config property file values. But out of the box, it should be very simple. It's turnkey.
Yeah, and right at the start, you talked about a consistent way of developing apps, delivering apps, a consistent way of running apps. So I've got health, metrics, diagnostics information, all delivered in a consistent way, all the instances of all my microservices.
Yeah, and you can use that information.
You mentioned in that piece briefly reactive web servers.
Yeah.
And a couple of years ago on the show, we had Jürgen Holler talking about Spring Framework 5 and how we introduced the Reactive Streams programming model.
Yep.
That's now included as part of Spring Boot. Can you maybe give us I know it's a big topic, but could you give us an overview of how Spring Boot works with Reactive Streams model?
Yeah. So reactive programming is not a new thing, right? It's a relatively new answer though to a old problem. And the problem is, how do we handle more users? And how do we handle more requests? How do we handle more, right? How do we do more with the same computer? And I think for a lot of people, one important realization was that there's this lost opportunity. There's this missing opportunity in all of our programs and our applications and our systems. There's this missed opportunity because we have lots of things that are sort of asynchronous, that are latent. We wait for things to happen, right? And when we're waiting for things to happen, a lot of times we're sitting there on this thread waiting for that thing to happen.
So what kind of things do you mean?
Well, we call another web service, or we send data to a database, or we do something that's CPU bound, but we're doing it on the thread pool that is being managed, that is being kept to handle web requests, right?
Okay. Yep.
All these things that are either network I/O bound or I/O bound, or they're sometimes CPU bound, but they're being done in the wrong place. Either way, we've got a finite number of threads in our web server, for example, and we've got this work that we're doing, and that work needs to be as quick as possible. We need to get off that thread. And so a very common thing is to say, okay, well, I'm going to move this work into a separate thing. I'm going to create a processor that I connect to via a queue. And the whole point of that is to move work off of my web application, to move it off the main path for web requests, for example, right? And this is all problematic. The reason we do this is because we're trying to limit the number of threads that we've got, right? Threads are expensive on the JVM. Actual threads, like carrier threads, operating system threads, are expensive.
Yep.
On the JVM, they're backed by operating system threads, and those are expensive. What we want to do is make more efficient use of the finite number of threads that we have in our system. And so this gets us to the idea of cooperative multi-threading, right? Where through some work on your part, you give the runtime a clue or a cue about whether you're done with a thread or not. So it's slightly more invasive in that it's not just a generic opaque thread. You're no longer able to say, hey, run this code and let me pretend I have the entire box to myself. Give me my own context, my own stack, and my own thread of execution, right? It's not completely isolated processing unit now. Now you have to give signals to the runtime. You can say, hey, I'm not using this right now. I'm waiting for something, so you can have the thread back. It's yours. Just park me over here off to the side, and I'll continue in this wait state. And when something happens, I'll ask for more time on the thread, right? Cooperative multi-threading is not a new idea, and there's a lot of different ways to see that support manifest in an application. There's a lot of different ways to do that on the JVM, and indeed across multiple languages. So Erlang is very famous for having a very particular actor-based model, right? That's a very, very opinionated, very rigid approach to concurrency, and that in turn inspired things like Akka. A lot of different ways to do cooperative multi-threading. The point is, we need something like that. We can't just continue pretending that I can run anything I want on a Java Lang thread, and there'll be infinite threads. We have a sort of a half-step measure that we can do in 2019, and that we've been able to do for the last 10 odd years, where we can say, okay, well, my application is intrinsically inefficient. It's wasting time on these threads, but I can build a microservice, do a 12-factor style application where I have as little state as possible in each of the nodes, and I put those, now that I've got that kind of application, it's cheap in terms of complexity and in terms of cost for me to spin up another instance and then put that behind a load balancer, right? Because there's no state to replicate from one node to another to keep it consistent, so
yeah.
So that mechanism has allowed us to scale out, and it's a fairly pragmatic middle ground. I think you can scale out and handle more users, but you're still wasting a lot of capacity.
Yeah, but you're not really solving the problem.
Right, yeah. So the way to do it is to go to cooperative multi-threading, and reactive programming, I think, is the best bet for now for the JVM. Okay, so reactive programming is this idea that you have a runtime, you have a scheduler, and you embrace things that support asynchronicity. You model that asynchronicity using these types that let you work with streams of data that are potentially unbounded, potentially latent, and you have a built-in API. It's like a completable future, except that instead of just getting one value, you can get 0 or a trillion or a never-ending stream of values, right? Also critical to this is the insight that software is just, when we build software today, most of the time it's a distributed system. We're talking to other things. And as soon as you've got one computer on the network talking to another, you get into this discussion of back pressure or flow control, client-managed flow control. I, as the client, want to be able to stop or at least stagger the production of the data from the producer, right? Otherwise, I risk becoming overwhelmed. I risk being, denial of service, if you will. And so that's critical. That flow control is absolutely fundamental to the way distributed systems work. It's present in all network infrastructure, and all network programming has to deal with this. And yet, by the time we get to our typical application today, at the very tippity top of the abstraction stack, sitting on top of HTTP and all these other things, we don't even deal with it anymore. We don't even see it there. It's just assumed that it's being handled, hopefully well, by some lower level thing. But as often as not, that's just not the case. And so reactive programming is both a way of describing asynchronous streams of data and a way of contending with or grappling with the realities of distribution. The fact that there are going to be, that you need to manage flow control, and the fact that there are going to be errors. Errors are not exceptional, they're not special, they're just another kind of data, and you should deal with them in a consistent way. There's not a separate control flow mechanism. Now, all of that is fairly abstract. What it means for the average user is that they get an API that looks kind of like the Java 8 Streams API with some very pronounced differences, namely that you have support for back pressure. You can actually push back on the producer, and it works fine. And then if you write your code using this API, using these reactive streams types that were introduced not in Spring itself, but as the result of a joint initiative by a number of different organizations, including Pivotal, the Eclipse Foundation, Netflix, and Lightbend, nay TypeSafe. All of us got together and extracted out these common ground types into the reactive stream specification. These types fill a non-trivial hole in the JDK, so non-trivial that eventually in Java 9 they were actually packaged, in exactly the same way, except for the interface in Java util concurrent.flow, where flow is a top-level type. So these types are ubiquitous now. They're in the JDK as of Java 9, and so when you do reactive programming, you can use these reactive streams types that were extracted out into this little this de facto specification that these different organizations created years ago, or you can use the implementations in the Java 9 Java util concurrent flow type. But they give you portability, they give you interoperability. You can take your reactive code that runs on Spring's support for reactive APIs called Spring Webflux, and Spring and Reactor. Our project that supports reactive APIs is called Reactor. You can do that there, or you can take a reactive stream that's been produced by, let's say, Akka Streams, right? You can use that with Spring Webflux because they both speak the same language. They both understand each other's idea of a reactive stream. And our reactive support, this cooperative multi-threading support that we have in Spring and in Reactor, that support, once you've made that cognitive jump, once you understand that you need to give the runtime some idea about when you're no longer using a thread, such as when you're making an asynchronous network call, like an asynchronous IO based network call. That idea, once you've understood that and you've written your code in such a way that works, some interesting possibilities open up to you. Already today in 2019, there's Kotlin. Right? Kotlin has coroutines. And so coroutines it's the idea of, okay, well, I've got these breaks in the action in my program, these asynchronous islands of inactivity where I want to just get off the thread and wait, and I'll let somebody else use that thread. And you have to, if you're willing to teach Kotlin through its API about these breaks in the action by teaching it about something, you basically teach it about how to adapt this asynchronous thing like a publisher from the Reactive Stream spec. You teach it how to integrate that with its own notion of an asynchronous thing, and then it will let you write that code. It'll let you write this code in a way that looks kind of synchronous. It looks like it's imperative, but behind the scenes the compiler rewrites it so that the call stack of a statement that succeeds or that follows an asynchronous operation is actually invoked in what is basically a callback. But to you, from the perspective of the person writing the code, it just looks like you did statement 1, 2, and 3. Statement 1's on one line, statement 2 on the second line, statement 3 on the third line. What's actually happening is that behind the scenes, statement 2 somehow does some sort of asynchronous thing, and when the asynchronous thing completes, it then calls statement 3, right?
Okay.
So you write code that looks, it's a callback. Behind the scenes, it's that callback that it rehydrates the state that statement 3 was expecting to have when it got to statement 3, and including all the variables in scope and all that. That's called a continuation.
So I've not seen that in Kotlin.
Yeah.
So the reactive streams model, it's not something that you can take on lightly. It's rewriting the application to use a different programming model, and you processing streams in a functional way, yielding control to the threads, just like you say. And that Kotlin now provides some language features that help you slot that into a more familiar imperative style.
Right, and so there's the Kotlin. This was just released in Kotlin 1.3. The support itself, the support itself is there's only one keyword that was added to the language proper, and it's called suspend. Right, that one keyword is what allows Kotlin to understand. You have to write code. You have to adapt existing asynchronous types like a reactive stream. You teach Kotlin how to adapt that into its own idea, and then it'll just work. So you can everything you understand in the reactive APIs, now you can use in coroutines, right? So we've already done that. They have a separate project that doesn't live in the Kotlin language itself. It's just a separate project maintained by JetBrains that contains all these adapters. So if you want to use Reactor or RxJava or Futures or whatever, there's all these adapters that teach the Kotlin runtime. Think of these asynchronous things as coroutines.
So have you got an example of that in a sort of simple web application?
Yeah, do you want me to, you mean like in a Git repo or something?
Well, possibly. If we've got one, I'll definitely put it in the show notes. But
sure. GitHub.com, Spring Tips. It's spring-tips, and then it's KOROUTINES. It's GitHub.com, spring-tips /coroutines. I even just did a video on that. But the benefit of that model is that if you're using Kotlin, and it's a lovely language, I don't know why you wouldn't. If you're using Kotlin, you can write code that takes advantage of these reactive APIs, but to you it just looks like you're just saying, okay, the result of this query equals this, and it's not a promise or a completable future or whatever. It's just the actual object. And it looks like you just got the object from a direct call, and it looks like you blocked, but behind the scenes, it's actually an asynchronous reactive call, and the method invocation pauses. It actually stops working, and it packages up the state into this continuation, and the continuation gets invoked on a callback in a separate thread later on. It is absolutely magic, amazing.
Okay, I'm definitely going to take a look. The reactive model is something, it needs to be used everywhere. Of all the components in a sort of typical enterprise stack, are they all now available with reactive APIs?
Definitely not, no. So one of the biggest roadblocks, if you want to build a web application, the Servlet API doesn't really support async. It supports async request and response, but for example, resolution of session information, cookies, that kind of stuff, that's not reactive, which is fine. You're probably not going to notice it. So we actually have an adapter that runs Spring Web Flux on top of existing Servlet APIs, so that's an option. But we just prefer, by default, if you do Spring Boot, if you add Spring Boot Starter Web Flux, FLUX, what you get is a reactive web runtime based on Netty that gets added to your class path, and that just works by default. There's no Servlet API there at all, no dependency there, and it's optimized for being a reactive web runtime. But then, and I think that was actually the easy thing, right? Providing a brand new web runtime is the easy part. The hard part is these more traditional sort of enterprisey things like SQL data stores, or even data stores in general, right? Not all data stores provide asynchronous IO based drivers. And so it gives nobody an advantage to uselessly adapt or provide a facade on top of a blocking API that makes it look like it's reactive without actually being asynchronous, right? If I call into JDBC is a fundamentally blocking API. It doesn't matter how much I adapt that API to look like it, it's still going to waste a thread behind the scenes, underneath the hood there, right?
I remember I've listened to the show with Jürgen Holler again recently, and he was talking about how a database transaction by its very nature is not reactive, and it is there to lock rows in tables and make you wait until the work is done. Right,
exactly. So that JDBC is a very common one, but even like Neo4j, up until just yesterday when they made public their reactive Neo4j driver, right? And their Spring Data module. Up until then, there was no asynchronous and non-blocking version of Neo4j. Ditto for most of these different data stores. To be fair, Couchbase, I think, was the first one. Couchbase had a asynchronous I/O reactive driver. Actually, their implementation by default is built on asynchronous I/O. So when it came time to build the Spring Data adapter for that, the Spring Data integration for that, it wasn't very difficult at all because it was already natively reactive. Ditto for MongoDB. They were very early. They had a very good, very workable, very usable asynchronous I/O driver. And that was one of our first supported Spring Data modules to support asynchronous reactive programming. Cassandra and Redis followed suit very shortly. But SQL has always been the sort of thing that people wanted to use because, of course, I think that's still the prevailing thing. I think if you ask any group of developers, you'll find that the prevailing plurality, at least, is SQL. So we have a project called R2DBC. R2DBC is an abstraction. It's an SPI that provides a reactive approach to SQL integration, and it's not tied to Spring. It's just a separate project. It's written in terms of the low-level Reactive Streams types. There's no dependency on Reactor or Akka Streams or RxJava or any of these other reactive runtimes. And that, in turn, provides our project, R2DBC, in turn ships with a number of drivers that implement this SPI. So we've got out of the box support for PostgreSQL.
So an SPI is a service provider interface.
Right.
And it's a way for people to adapt to a standard interface for dealing with something like a relational database.
You got it. And it just like JBC, right? JBC is just a set of interfaces, but you need an implementation for that to be usable and meaningful. So we have an SPI. We have a number of implementations, of which we have PostgreSQL, Microsoft SQL Server, and H2. There's a third-party one called JASync, JASYNC. That's a third-party project, and they have an implementation for MySQL. And I can tell you, there's almost all the major databases with which you'd want to connect. I don't know about Oracle, but I know that almost all of the major ones that you can imagine wanting to connect to, or at least all the major ones I want to connect to, have or are going to have soon work being done or have already done work on an R2DBC driver. So there's a large coalition of vendors that want to support this, right? That want to work on this. So I think it's exciting. Right now, it's like I said, it's limited to those 4 right now, practically speaking. So if you're not in that group, then reactive programming may not be for you, right? That's fair. If you're not using Cassandra, Redis, Couchbase, and MongoDB, and now Neo4j, it may not be for you. That's fair too, right? You can still use these things from a reactive application, but you're going to end up blocking threads. So you have to scale out those interactions by adding more threads, which is sort of contrary to the point, right?
Yeah, exactly. But with R2DBC.
R2DBC, it's a reactive relational database connectivity. So R2DBC.
Okay. Yeah, that's bridging the transactional processing of databases with a reactive model.
Well, so that brings up another great question, which is, so you can do transactions in R2DBC, and you can also do transactions in MongoDB, and actually we can do transactions in both R2DBC and MongoDB in the reactive versions as well. So the question then is, how do we do transactions in a sort of, how do we model that innately interesting thing in a unified way? So in Spring Framework, we've long had this idea of a platform transaction manager, which is a low-level type which has 3 methods. It allows you to get a transaction, it allows you to commit that transaction, or to roll it back. And that abstraction has a number of implementations. There must be dozens of them at this point that talk to anything that you can imagine modeling as having a transaction. So JTA, Java Transaction API for distributed transactions.
Yeah.
JPA has its own concept of resource local transactions. JDBC has its own concept of resource local transactions. Ditto for JMS. Ditto for JDO. You might remember JDO.
Yes.
Ditto for Hibernate itself, specifically. Ditto for Kafka. Ditto for RabbitMQ. Ditto for Neo4j. Ditto for this unending list of things that have their own concept of resource local transactions. We have implementations of that interface for all these different things. And if you want, you can use an implementation of that interface in your Spring code. You can then use that with something called the transaction template. And the transaction template lets you run code inside of a Lambda in the context of a transaction. If there are any errors or exceptions, then the transaction is rolled back. Otherwise, it's committed for you. And you can go a step further. You can, instead of enclosing transactional logic, instead of demarcating that transaction using this transaction template, you can use the @transactional declarative annotation on your method, and that'll demarcate a transaction around it'll enclose your method in a demarcated transaction for you automatically. that interface has been there since the very beginning of Spring. It's one of the most useful things of Spring. And so we were looking for a way to support that same kind of convenience in the transactional world. But here, as you just alluded to, things are quite difficult because the assumption with Platform Transaction Manager is that you've got thread local storage. Well, of course, as transactions jump the thread of execution, quite often, as reactive transactions jump thread of execution quite often, they go from one thread to another in the same transaction.
Yeah, you've got to get off the thread as soon as possible.
Right, and so it no longer makes sense to stash the state, the storage for the transaction. It can't be associated with just one particular thread because that no longer is the prevailing truth. It's not true that one thread will always be the one being used for a transaction. So we needed some way to recreate that. We've created a reactive transaction manager interface, and the first two implementations that we have already are for R2DBC, for SQL Data Store Access, and for MongoDB. Right.
Okay.
So now you can use the reactive transaction manager, and what that does is behind the scenes, it's using a mechanism in Reactor to propagate contextual information in the pipeline itself, in a reactive pipeline itself. So it's storage that's associated with the pipeline, and that gets propagated from one thread to another for you automatically.
Okay.
You can think of it as a dictionary or a context that gets added to each pipeline, and you can use that. And we use that behind the scenes as a generic mechanism for propagation of security information, credentials, that kind of stuff, context rather, principal information in Spring Security, reactive Spring Security. We use that for distributed tracing with Spring Cloud Sleuth and things like Zipkin, right, and open tracing that we can automatically trace reactive requests that way as well.
So every time you yield control, every time you get a callback, there's this context that's carrying the information that previously you could have just stored in a thread local.
Right.
But now it's got to be managed all the way through the stream processing.
Well, I mean, you don't end up having to manage it, right? Spring does it for you. But yeah, it's something that's true before. Something had to make sure you started and then cleared the thread local as well. So the point is Spring is doing that for you in the case of the thread local, and it's now doing it for you in the case of this context object. And it's a generic abstraction. The context is something you can use as well. I did a Spring Tips video, for example, on heavily, like almost entirely inspired by Simon Basle's amazing blog demonstrating how to bridge MDC with reactive, right? How do I take a log context and then map that to a reactive transaction, for example? So so you can do that as well using context. It's this generic mechanism that allows you to do that, and we do that for transaction management now. So we have a reactive transaction manager, and then we have a transactional operator, which is more or less similar to the transaction template, but it's analogous for the reactive world. And I did a Spring Tips video introducing all of this as well just recently, for those of you who are interested.
That's another one for the show notes. We'll follow up I'll follow up on that separately. And we touched on some issues there with Spring Cloud, Sleuth, huge topics. I think Spring Security, we mentioned, we could do another show.
Happy to.
So I think I might take you up on that. That's a great place to wrap up, I think.
Cool.
Yeah. So where would you quickly recommend people go for resources about Spring Boot?
Oh dear. So the best resources are, of course, spring.io/guides. These are 10 to 15 minute long digestible bits of information. They're little things that you can read that'll teach you one little trick, like how to build a simple REST API. And it's not everything you need to know about REST. Okay, it's just how to make Spring Boot create a simple HTTP endpoint that you can then use as the basis for your explorations of REST with Spring Boot. It's the make it wiggle factor, right? If there's dozens of these little recipes, I want to send a message to Kafka. I want to use a circuit breaker. I want to do centralized configuration. I want to do OAuth. Whatever. There's a bunch of these guys, right? That's one great place. I have a playlist called Spring Tips where every Wednesday I publish a new video. Before we got on the line, I was making sure that got uploaded for today's installment, and it's bit.ly/spring-tips-playlist. I also do a podcast every Friday. It's not as nice as this one, of course, but it's available wherever fine podcasts are purveyed. It's called A Beautiful Podcast.
Excellent.
The documentation is legendarily good. And also, if you want to contribute, dear audience, we love people that want to contribute to the open source world. We have, in most of our projects, we have in the GitHub issue tracker, we have projects that are labeled open for feedback or ideal for contribution or whatever. These are things that are ideal for people who are aspiring to become people that work in the community, the open source community, and they're not sure where to start, and it can be kind of overwhelming to try and influence a giant project like any of the Spring projects, right? If you want something where it's an easy place to put your feet in the water, and we're going to be very happy to help you. There's a bunch of these issues. Just find one, say, hey, I'd like to tackle this, and we'll support you on that, and we'd love to see you become a contributing member of the project. People ask that all the time.
Fantastic.
And then one more plug. I have a book I'm working on called Reactive Spring. You can go to leanpub.com, and it's reactive. And just go to reactivespring.io, and you'll find the link to the book. You can buy it now. It's early access, and you're entitled to the full book, the final book when it's done, and you can feedback and give me contributions.
Okay, and we can watch it as you complete it.
Yeah, exactly. And so it's an agile platform for publishing books. This is the first book I'm self-publishing, and it's really been a really amazing experiment. I've never done this before. I didn't know how exciting this could be. I thought it might be. I know how exciting it is to get people to be interested in your software and to get them interested on GitHub. But this is that same sort of process, but for books. And I actually write the book and release it using software tools, right? It's a continuous delivery platform, a continuous delivery pipeline that I built to publish this book. So it's very iterative, a very, very interesting experience.
Brilliant. Okay, great. Well, Josh, leave it to say thank you for coming on the show.
Well, thank you so much for having me. Absolute pleasure.
Yeah, it's been a real privilege. It's been great fun talking to you.
Ditto. Likewise.
So thank you. This is Simon Crossley for Software Engineering Radio, and thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.